morning, everyone. This is Sachin Fiske from Electrical Engineering Department, SND College of Engineering and Research Center. Today, we are going to discuss the block reduction techniques. This was the previous part. In the previous lecture, we discussed about the transfer function. So, according to this diagram, we can conclude C of S upon R of S is equals to G of S, means the definition of the transfer function. The given diagram indicates the single block diagram representation of a particular system. Here, R of S is the input, C of S is output, and G of S is the transfer function or gain of the system. It is single and only in indicated direction. So as per the definition of transfer function, C of S is equals to G of S into R of S. These are some conclusions. Here, the signals given are R of S and C of S. Figure B represents R of S is given to the gain, that is G of S, and from this G of S, C of S is the output. According to diagram A and B, we can see the diagram C. The combination of this diagram A and B includes one summing point, that is shown in diagram C. Here R1 of S, R2 of S and R3 of S are added and subtracted respectively with this summing point. So according to the definition of transfer function with respect to figure B, this C of S is equals to R1 of S plus R2 of S minus R3 of S, because R1 and R2 are positive indicated towards the direction of summing point and R3 will be indicated as a negative. So these are the main functions of summing junction. Now see in the diagram D, it is the peak off point, means R of S will be considered as input, and this R of S will be divided into three parts which are the parallel from a common junction point, that is R of S first line, second line R of S, that is middle line, and last line is also R of S. These components of linear time invariant system means LTIS system. See the block diagram component. The same previous component will be attached and form a large diagram. But in the previous diagram, only single gain will be there. Here, two gains and one feedback system will be provided. The two gains, that is G1 of S and G2 of S, are in series, and one feedback loop, that is H of S, will be provided. So here R of S will be input of the system, C of S will be the control output of the system, and one feedback element from G2 of S to R of S, that is H of S, will be provided. This summing point will be indicated as E of S is equals to R of S plus minus B of S, and B of S means feedback element is indicated. See that one disturbance is also added, that is U of S in this diagram. So as per the definition, this G of S is equals to direct transfer function, and it is again equals to forward transfer function. H of S will be the feedback transfer function. G of H into H of S will be the open loop transfer function. C of S upon R of S will be the transfer function, or we can say that it is a closed loop transfer function, or it is a control ratio. And last one is C of S upon E of S is the feed forward transfer function. The diagram indicates a closed loop system with a feedback element. Therefore, C of S upon R of S is equal to G of S upon 1 plus G of S into H of S. Now we are moving towards some simplifications. That is, first simplification is cascade or series connection. As per the same diagram, here the three gains are given, that is G1 of S, G2 of S and G3 of S. See diagram A. Here in between G1 and G2 here x2 will be provided. So how this x2 will be obtained? So s2 r of s and g of s, that is x2 of s is equals to g1 of s into r of s. Now we get x2 of s, but after the block or gain g2, how this x1 of s will be obtained? So g2 and the combination of rs and g1, that is x2. So x1 of s is equals to g2 of s into g1 of s into r of s. And similarly, our output is c of s. So how this c of s will be obtained? It is the multiplication of g1 of s and g2 of s. So the output obtained from g1 of s and g2 of s will be the output of c of s. So c of s is equals to g3 of s, g2 of s, g1 of s into r of s. Now, a simplified block diagram will be obtained as consider r of s and c of s, and the complete output, that is c of s, will be written in the block, that is g of s into g, g1 of s into g2 of s into g3 of s. This is all about the simplified cascade connections. Here the parallel connections are given. So how this parallel connection, it is again as same as that of the series connection, but the rules are somewhat different. R of s will be input, C of s will be output, but R of s will be pickup point here, that is G1 of s, G2 of s and G3 of s. So the output of G1, G2 and G3 are again completely different. So for G1 of s here, the output will be x1 of s is equals to r of s into g1 of s. For g2 of s, the output will be x2 of s is equals to r of s into g2 of s. And for g3, again same, it is r of s is into g3 of s. At the same pickup point on RHS side, all are positive and negative. So C of s is equals to plus minus G1 of s plus minus G2 of s plus minus G3 of s, and R of s will be considered as pickup point. So it will be multiplied to all these gains factor, that is R of s. Therefore, the simplified block diagram will be R of s and G of s, in between them as a gain, that is G1 of s, G2 of s and G3 of s. All are in plus and minus connections. So the algebra for this summing junction will be given in following table. That is, see in the first diagram, R of s and x of s will be added at a summing point. So R of s will be positive and x of s will be positive and negative. Here gain G of s will be provided and C of s will be the output. So it is equivalent to R of s, then gain G of s. Let us take this shifting point x of s. So in between we have to take the gain same, that is G of s, and what is the input to this gain G of s? It is x of s. So what is the value of for diagram A? It is C is equals to G in bracket plus R plus minus x, or by solving this we get it is equals to plus gr plus minus g x. Now consider figure B, r of s. Here x of s will be the after the gain. So what will be here? When we are transferring this x of s to the left hand side of the g of s, it should be divided by 1. Okay, so r of s summing point will be given, so it should be considered as 1 upon g of s, and it has one input function, that is x of s. Therefore c is equal to gr plus minus x, and g will be the output of the bracket, so plus r plus minus x of g, because it is 1 by g. And when 1 by g of s is multiplied with x of s, so it will be the x by G. Now moving towards this block diagram algebra for the branch point. Here R of S will be given to G of S in the first row. So what is output? It is R of S into G of S, and similarly R of S and R of S will be again equals. So Whenever we are shifting this G of S in the second and third line, it should always be 1 upon G of S and 1 upon G of S, and R of S will be same. But what should be in the first line? It is same as R of S into G of S. But we have to take it out towards the pickup point. These all points are considered as a branch point or loop point.